In this problem, we're asked to graph a parabola. We're given our equation. And the first thing that I'm going to do is to find the vertex of my parabola. And I can do that using negative b over 2a, expand this out and do negative b over 2a, or I can use the vertex formula. I can also actually just put this into my graphing calculator and graph it and figure out what the vertex is. I'm going to use my vertex formula. So you can see here that my formula doesn't quite match up because I need to have subtraction in my formula and I've got addition, so I need to rewrite my equation. Now I can see that h is going to be negative 3 and k is going to be positive 2. So my vertex is the point negative 3, 2. Next thing I need to do is to go to my graphing calculator and look at the table. So second graph will get me to the table. And I just need to find another point in my table that I can plot here. And I'm just going to use the point negative 1, 6 just because that's the first thing that popped up in my table. So I have that point plotted. If you're in my math lab and have that second point plotted, then usually my math lab will go ahead and give you a corresponding point over here using symmetry, and then go ahead and sketch in the parabola for you. So once you click save, the parabola will be there. Okay, I have found the vertex of negative 3, 2. The next thing I want to do is to determine the axis of symmetry. The axis of symmetry is this line that goes right down the middle of my parabola. It goes through the vertex, and this line is a vertical line. I know that the equation of a vertical line is x equals some number, and that number is going to be, in this case, negative 3. And this axis of symmetry, this number here, is always the same as the x-coordinate in your vertex. Now, in case you forget whether this equation is supposed to be x equals negative 3 or y equals negative 3, refer back to your reference sheet, and on your reference sheet it does give you the general form for vertical and horizontal lines, so you will know that this is a vertical line and the equation is going to be in the form x equals some number. The next thing I'm asked to do is to determine the domain, and there's actually a couple of different ways that I could go about figuring this out. I could look at the equation itself and figure out where is my equation defined. Well, I know that with this equation, any real number I put in to my equation is going to give me out a real number. So my domain is going to be from negative infinity to positive infinity. And I can also figure out the domain by looking at the graph. My graph is going up and then forever wider toward the left and right. So again, forever negative infinity and then toward positive infinity. Now the range is bottom to top. So how far low do I start and how far up do I go? Well, how far low I start in this problem is 2. And this range is always going to be associated with this y value here. So in this case, I'm going from 2 to positive infinity. So a couple of things about the range. First of all, if I want to include that 2, and I do, I need a bracket at 2, but remember infinity always uses parentheses. Now if I have a parabola that opens down, my domain is still going to be from negative infinity to positive infinity, but my range from bottom to top is going to be negative infinity up to positive 3. Again, I'm still associating my range with my y coordinate here, but it's different than the range in the problem that I saw previously, whether I'm going from a point up to positive infinity or if I'm starting from negative infinity and going up to a maximum point.